Hello ladies and gentlemen, in this video segment we're going to learn how to draw free body diagrams in 2 dimensions and to calculate the net force in 2 dimensions. So in this scenario here we have a sled with a total mass of 10 kilograms. The sled is being pulled with a force of 80 newtons, okay, and that is represented up here, right? The force applied is 80 newtons. The sled experienced a force of friction of 40 newtons, which we can see right here. The normal force experienced by the sled is 58 newtons, represented up here. And the question is asking for you to determine the acceleration of the sled. Now, whenever you do force problems, you want to always break it down into the F net equation. And remember, your F net equations can only be written in the X and the Y planes. Okay, so if you have a force that is going at an angle like we see over here, then what you have to do is you have to break this force into its X and Y components. Alright, so I'll draw the X and Y components in to show you what exactly I mean. Alright, so that would be my X force, okay, and I'll draw the Y force in green. And this one right here will be my Y force. Alright, so you want to break it down into the X's and the Y's. Okay, and we can do that using trigonometry. So let's do it here. In order to find the X component, I'll do the math in purple. We have this triangle with the hypotenuse being 80 newtons. Okay, so we can state that the adjacent side is the X side. Alright, so if this is the angle right here, 30 degrees, this purple side is the adjacent side. Now, whenever you're finding something that is in the adjacent side, we're going to be using cosine. Okay, cosine of theta is equal to adjacent over the hypotenuse. So we have cosine of 30 is equal to adjacent, which in this case would be f of x, over the hypotenuse, which is the force applied. Okay, so we can rewrite this by saying the cosine of 30 is equal to f of x over 80, and we can multiply both sides by 80, to get f of x is equal to 69.3 newtons. And I'll write that in our diagram here. Okay, our f of x is 69.3. Now let's find our y. Okay, and the y is represented by the green, so we'll stick with the green. That green side is opposite of the 30 degrees, and so whenever you're dealing with opposites, you're going to be dealing with the sine function. Okay, sine of theta is equal to opposite over hypotenuse. We have sine of 30 is equal to f of y over the hypotenuse, which I'm just going to write in as 80. Okay, So we can multiply both sides by 80 to get rid of the 80 in the denominator. And we get f of y is equal to 80 sine of 30, and plug that into the calculator and we get 40. Alright, I'll write that 40 in right there. So that's just setting up the entire problem. And what you want to do now is you want to create a fx net. And I'll do that right down here. fx net. Now, this just means that we are going to add up all of the x forces. Okay? So here we have the force of friction being 40, but because it's going to the left, it's going to be negative 40. We found that the f of x applied was 69.3. Alright, and we find that our fx net is equal to 29.3 newtons. Alright, sounds good. Next, we want to find our fy net. Alright, we have positive 58 from the normal force. We have negative 98 from the weight, or the force of gravity, and we have positive 40 from our Fy applied. Okay, and if we add this up, we actually get 0. Okay. Now, at this point, we want to find the total force that is being applied to the sled. So in order to do that, you are going to use the Pythagorean Theorem to state, so you're going to use this equation. Let's see here. Force squared is equal to f of x net squared plus fy net squared. Alright. We know that fy net is 0, and this is just 29.3 squared. Okay. I'm gonna skip a step here and just gonna square root both sides, because anything added to 0 is itself. Okay, if we do that, we get f is equal to 29.3. Okay, I'm gonna go over on this side. So we know that the force is equal to 29.3, and it's asking for the acceleration. So we have to use the equation F is equal to ma to determine the acceleration. Our force is 29.3. Our mass is 10 kilograms, and we need to find the acceleration. Divide both sides by the acceleration, and we get acceleration is equal to 2.93 meters per second squared.